Hi, my name is Gabe Hollenby. I am a technical evangelist at AWS. It's a funny title, I know. What does it mean? It means I'm a software developer who also likes talking to people. So I've been building apps for many, many years, and a lot of those years have actually been building apps on top of AWS. And now my job is to learn all about what AWS has to offer in our different services and come and share that knowledge and all the cool stuff you can do at events like this. I love my job, and thank you so much for taking time out of your busy schedules to come here today and to learn from me and from all the other speakers. Really appreciate it. So today I'm going to talk about the Internet of Things. And I always like to just get a little bit of a level setting before I get into my talks, understand a bit from the audience. So can I see a show of hands, if you don't mind? Put your hands up if you've heard the term Internet of Things before. And okay, good. Most everybody, thank you. Keep your hand up if you've actually done something with Internet of Things before. Awesome, good. That's like at least half the room. Sweet, okay. Well, I think you're going to see some really exciting stuff here today, and let's just get right into it. So I want to start with the question. If you knew the state of everything, and you could reason on top of that data, what would you do? Really think about it for a second. That's the mission that we have at AWS with our IoT services. We want to make the answer to this easy for you to figure out. We want to give you the tools you need to have thousands or hundreds of thousands of devices out in the field, sending data up to the cloud, working offline, synchronizing state, managing it, making local inference when you don't have an internet connection, the whole thing. We want to make that possible for you. And so you just need to decide what you're going to do with those possibilities. Now, we have a lot of customers already answering this question for themselves. You know, the people in the connected car industry, companies like BMW, Nissan. We've got food and beverage companies. Well, we've got Simplistic right here in India. I'll talk about them a little bit more in a minute. Nestle, consumer electronics, Philips, mining, Rio Tinto, a lot of different use cases. Symantec with Norton. They make the Norton Core Home Router that uses AWS IoT for their product, and that's known for its security. We've also got iRobot. They make the Roombas. A lot of my friends have Roombas. And you know, you can use, or I should say iRobot uses AWS IoT to let the customers manage their Roombas over their Wi-Fi networks and online. And so what is IoT, though? Let's just talk about that in a little bit of a basic sense first before I get into the really neat stuff. At its core, the Internet of Things is simply two parts. You've got a bunch of devices that are collecting data. They've got sensors on them. They're sensing information about the world. And you want to unlock that data. You want to do something interesting with that data. And that means taking the data from the device and getting it up into the cloud where you can analyze it and you can enrich that data and you can compare with other things. And that's where you're going to get your real business insight. There's no sense in just having a bunch of devices producing data if you can't do anything with it. And so to start out, we have our IoT core services. Now, this will handle things like the core messaging. So we'll give you an endpoint that all of your devices can securely communicate with certificate authentication and encryption. And once you've got your data sent up to the cloud, we've got a message broker and a rules engine that will let you dispatch those pieces of data, those events, to different sources, whether you just want to record that data or whether you want to take action on that data, fire off Lambda functions, this sort of thing. And finally, state management, right? So in IoT, you have devices that are not always online. And so we make it easy to do things like remember the last state that a particular device was in and its configuration and information about it. And if you want to make changes to that state, you can make changes with API calls without the dependent on that device being online at the time. And when the device comes online, we'll handle that state synchronization for you automatically. And so I mentioned Simplistic before. They've got this, the Rotimatic. Does anybody here have one of these? Yeah? So, is it cool? It looks really cool. I totally want one. I love rotis, and I would definitely use one of these at home if I had it. I live in Singapore, but I think it's a little bit big for me to bring back on the plane. So they have sold more than 20,000 units of this worldwide. To date, according to their website, over 17 million rotis that they've made. And what's cool about this device and how they use AWS IoT is it lets them know the state of all these rotimatics and how they're functioning, and they can respond to customer problems before the customer even knows about it. If there's a problem with the device, it can phone home and say, this is my behavior, I'm acting a little strangely, and they can remotely debug if they need to. so they can also understand their customers' usage patterns better. And that's the end goal, right? You want to be customer obsessed. You want to be able to respond to your customers as best as you can. And so here's a great example of one company using the power of Internet of Things in order to stay in touch with their customers and build better products. Furthermore, they can roll out new software more easily and quickly. If there's a software update, they can get that out to all their devices much more easily because of the deployment mechanisms that AWS IoT Core makes possible for them. But we have a lot more than just the IoT Core. So we also have something called AWS Greengrass. What Greengrass is software that you can install on Greengrass-compatible devices at the edge. And what I mean when I say edge is not in the cloud, but somewhere close to, or in some cases on, the devices themselves that are sensing and producing the data that you want to collect. Greengrass has a lot of neat features and brings a lot of the power from the cloud to your local devices. Firstly, it can handle taking data from other non-Greengrass devices, so they can communicate directly with the Greengrass hub or some software, some device running the Greengrass software that that's compatible for running Greengrass. It's encrypted automatically, so we also handle the secure encryption. Greengrass devices can act as a local certificate authority, so you don't have to worry about your devices communicating securely. We manage all of that for you with the certificate management. It'll also do that offline state synchronization I talked about, supporting device shadows, if you know, or I'm sorry, thing shadows, which is the term we use in AWS IoT to talk about a device and when it's online or offline and doing state synchronization. And finally, the coolest feature, I think, is the ability to use the same execution model that you could have in the cloud to respond to events locally at the edge when you might be offline. So developers can build applications and functions with AWS Lambda, and the Greengrass devices can run Lambda. So you can take the same code that you've written already to work with AWS IoT in the cloud, and those Lambdas can run locally on a Greengrass device instead. You don't have to change anything about it. And with Greengrass and IoT Core, that's still just part of it. We've done a few things recently. We've extended the services in the IoT family. So the first thing we've done is we've addressed this case of how do you manage fleet onboarding? It's one thing to get a couple IoT devices up and running, but it's a totally different story when you have thousands or hundreds of thousands of devices that you need to onboard quickly and manage the state of. And I'll talk about our solutions for that. Of course, once you've got these things all onboarded and running, your next problem is how do you keep them secure? How do you monitor them to make sure they're behaving accordingly? And how do you adjust and react to alerts for devices that are misbehaving? And finally, again, the whole point of IoT is what do we do with the data we're producing? And so as you have even more devices producing more data, how are you ingesting that data? And are you ingesting it in a way that makes it efficient and supports the kinds of queries that you might want to run? And we have some new features and services I want to talk about there. So let's get into it. And first, let's talk about that first use case of the fleet onboarding and management. So the question here is, how can I manage my growing number of connected devices, right? Customers were asking us this question as they started onboarding more and more devices. You've got Philips, right? They've got millions of devices out in the field, from MRI machines in hospitals to televisions to even toothbrushes. Or you've got Trimble. They are all over in many industries, automotive, logistics, agriculture, and construction. They've got millions of devices too. And as I said, you can't onboard these one by one. And you can't keep organized. You need some way to know what devices I have, can I group them into logical groups for management, and how do I track their state? So let me ask you a question. What if I needed to answer the question, all the aircon units in this building, what if I wanted to know how many of them have been running for 4 or more hours continuously at a current temperature of 18 degrees Celsius, and perhaps also of a particular manufacturer and have a particular firmware version. Because maybe in that specific case, I've just learned from my manufacturer that they're at risk and I need to service them. How could I do that, right? What if it wasn't just all the ones in this building, but all of the air conditionings across some big office building deployment, right? It could be a lot. How would you answer that question? So the first thing, again, is you want to onboard your devices, but after you've done that, the question is, how are you going to do real-time fleet indexing and search? How are you going to know the state of all of your things as you have more and more online, and not just what firmware version they have, but dynamic state about them too? I'm currently, this is my current RPM cycle, this is my current operating temperature, these kinds of things. And finally, how can I do over-the-air updates when I realize I need to for some reason? This is what AWS IoT device management does for us. So first is the batch fleet provisioning that I talked about. What this will let you do is easily onboard it and manage the certificates for thousands and many thousands of devices all at once. So you can think of it just like a bulk way to import your data. You can configure ahead of time what groups I want all of my devices in for easier management later. And once you've got them onboarded, you can take care of things like, well, the real-time indexing. Excuse me, let me go back. The real-time fleet index and search, right? So with IoT device management, you've got the ability to write these kinds of ad hoc queries and realize the state of your entire system at large. More importantly, there's fine-grained device logging and monitoring so that when you do discover things that you need to address, issues, you can issue the over-there updates, right? And it'll manage all of that for you. You can schedule the updates. You can say, this is when I need them to go out. And so maintaining your fleet health is something that the IoT device management suite of services will handle for you. You can remotely reboot your devices if you need to. You can put in new parameters, all of that. Next up, let's talk about auditing and protection. Security is job zero. We say that a lot at Amazon and AWS, and it's because it should be the most important thing. And in the IoT field, right, I would say many IoT deployments in the past have not been applauded for their high levels of security. And so it's really important that you bring a lot of powerful tooling to the job to make sure that your IoT deployments are secure. So how do you ensure that they stay secure? It's a fair question. You want to make sure that from the first day, you've got encryption set up correctly at scale. And you also want to make sure that it works not just for a few devices, but the millions that you bring online. And so the things you want to care about are knowing the state of your devices and from a security perspective as well, right? So setting your security parameters and monitoring behavior. So for example, I might say, this device has this certificate associated with it, and these are the ports it's allowed to communicate on, and this is the type of network bandwidth I'm expecting from it. But I want to detect drifts in policy and identify anomalies. Right? I want to know when some of my devices start acting strangely, either because of a software problem or maybe because they've been attacked or compromised, and so I can act accordingly. Once I know that there's a problem, I want to get an alert. I don't want to have to go looking at a dashboard all the time as my fleet is at scale, right? I can't fit it all on one dashboard. The tooling should tell me this device has a problem, so I can respond automatically or manually. And sometimes that response might be an automatic update, right? Like issuing an over-the-air update in response to a security concern. Perhaps it's reprovisioning the device's software that it's running automatically, so to bring it back in line with whatever security posture I was hoping it would have. This is what IoT Device Defender will do for you, and I'll just go through these one by one. So you can audit the device configurations, like I said. A good example would be, what if 2 or more of your devices end up sharing a certificate somehow? Well, you shouldn't have that. Each device should have their own certificate. So you can get a warning if that happens, if a device ends up with a non-unique certificate on it. You want to monitor your devices and identify anomalies. So a good example would be, again, a machine, a device, communicating on a port it's not supposed to communicate on, or maybe it's sending a lot more data than it used to. I should get alerts about that. Now, the alerts can go out to me in different ways, right? We can publish to SNS topics on AWS, for example, or you can route the messages in different ways. But you want to get alerts. And of course, you want to patch those security vulnerabilities. And finally, let's talk about data analytics and intelligence. And this is the most important, right, in my opinion. Also, besides security, this is the most important because at the end of the day, this is what you have your devices out in the field for. How am I going to generate value from my device data, right? Well, the data in the real world is often messy. Any of you who've done any IoT deployments, you know this is true. Sometimes you have outliers. Sometimes you have fuzzy data. And so you want to make sure that you have the ability to clean that data as it comes in. And not just clean it, but transform it and enrich it with other data sources. And then once you've transformed your data and you feel like it's good, you want to store it. But you want to store the raw data, and you want to store the data in an optimized fashion for querying in ways that your business needs to get at that data. And finally, once you're able to query it, you also want to make sure you can do some nice sophisticated visualizations and interactive analysis with that data. And that's exactly what the IoT Analytics service will do for you. So when it comes to the collection, you can collect from multiple sources. So of course, you can take data that's coming directly into IoT Core. You can combine that with data that's already on S3, or maybe data coming from Kinesis streams. You can blend it all together. And once you have your data from all of your different streams, you can pre-process it, you can enrich it. So an example I like to use here is you don't want to water your crops in the field just because your sensors in the dirt are saying it's too dry, right? Why would that be the case? Well, what if the forecast is 90% it's going to rain in the next hour? You definitely don't want to have your system automatically going to water it. So you can enrich your data streams from multiple sources, not just the sensors you have deployed, but also things in this case like the weather forecast to take more intelligent actions. And then once you've got that data stream ready to go and you can send it up to the cloud for storage, again, you always want to keep the raw data because oftentimes you don't know all of the queries you want to be asking about, all the ways you want that data to be shaped at the beginning. In fact, I would assert to you that you will always learn more as you go on with your deployments. And so it's important to keep the raw data, but also then transform it into ways that are optimized for querying at time series, which is what this IoT data usually ends up being. And AWS IoT Analytics is optimized for building that and taking care of that for you. Finally, there's ad hoc queries and quick site integration. So you can write queries in SQL, which most people are already familiar with. And you can take the data that comes back from those queries and use AWS QuickSight to build business intelligence dashboards and interactive ways to explore that data once you've got it ready. And finally, if that's not enough, right, you can go really deep, and we make it easy to take that data and also interact with it in Jupyter Notebooks. Perhaps also because maybe you want to train an AI model on some of the data that's coming in from your deployment. So we have, SageMaker is the service that we provide that will make it very easy for you to train, build, and deploy machine learning models, and you can integrate your IoT data with that very easily. And so that's really the structure, the state of the union of what we have going on in IoT architectures today. Again, Greengrass for offline communication with your devices, and IoT Core for the basics, device management for fleet onboarding, IoT Device Defender for audit and security protection, and finally AWS IoT Analytics for data analysis and management. And now, I would like to invite onto the stage one of our customers. His name is Amit Upadhyay. He is a CTO at MIX Lab. His company does a lot with telematics for the connected car industry and other industrial applications. So Amit, please come on board and share a bit about your experiences using AWS IoT now and in the future.
Yeah, so I represent MIX Lab, and Roller is our brand name for telematics and IoT products and solutions. We are part of Motherson Group. Motherson Group is a tier 1 supplier to almost all the automotive OEMs in the world. And these are our basic divisions. So starting from wiring harness, that's a primary part of the revenue of the company. Vision systems, defense and aerospace has been a recent addition to the group. Electronics and IT, of course, we do a lot of factory automation, not just for ourselves, but also for our own customers. So we have a captive IT company which does all this automation. So talking about the components that Motherson Group supplies. So as you can see, we supply lots and lots of components, starting from bumpers, mirrors, door trims, and intent is to increase the content per car every year. And also including vehicle electronics, and that's where we come in. We basically design and manufacture telematics and IoT and electronics products. These are our 4 verticals. Being part of Motherson Group, we of course supply our telematics devices to OEMs. We have a fleet management solution also, which is being used by a lot of B2B companies. We also open up our APIs for system integrators to build their custom solutions for or on top of our platform. We have IoT integration, so anybody wants to use our platform for embedding IoT solutions in their own products, that's also possible. And because we have this platform, we have now kind of scaled it to include use cases from industrial IoT also. And defense electronics is something new that we are venturing. Defense electronics probably the most precise form of electronics that you can have, and we try to build the same quality in all our hardware products. So talking about the roller IoT platform, right? So any IoT platform would typically have these three components. All right. So on one side you'll have these devices. So you have lots of devices starting from a basic telematics unit, going up to the infotainment system, which is probably 20 times more complex system. But yeah, again the core of this is having a connectivity in the device. Once you are connected, that's what the IoT means. Right, so then we have the IoT cloud. We'll delve more into the structure of the cloud, and then we need to build lots and lots of applications. So the idea is that once you have the data on the cloud, you can represent in different formats. So while an OEM may want a 360-degree view of what's happening with their latest cars, right, a kind of a location analytics, or they would want to know how their latest rollout car is performing, and they can have all this in a real time, right? Then fleet management, dealership onboarding, and retail users, of course, have an access to their cars on a mobile app. So talking about the hardwares that we have. So these are the different hardwares starting from infotainment. A Roller Mini is a plug-and-play device. Probably it's the easiest way to get a connected car if you want right now. You can just order it from Amazon and plug it in. Activate on the mobile app, and you have a connected car. A Roller SOS is a very special kind of device that we manufactured for one of our OEM customers. This is like a OnStar for agriculture. So this would be probably one of the first cases of using IoT in agriculture, agriculture vehicles. So what it does is basically, if the customer is having some problem, they can press a button and they are connected via hotline to the OEM, and the OEM call center can resolve the queries directly then and there. A Roller Pro TCU is an advanced version of the telematics unit. It has a lot of add-on sensors, like you could add fuel sensor or maybe temperature sensors onto this device. So this is how the telematics cloud look like, right? So there are three major components, I think, as Gabe already pointed out. So there is a device connectivity part, there is the cloud backend, and then the presentation and UI layer. So as you can see, the cloud backend actually is pretty complex. There are so many different modules that you need to build. And when we started 4 years back, we had to start from the ground up, building each and every components, such as the device connectivity gateway, firmware management, analytic algorithms, customer identity, device management, and so on. Unfortunately, at that time, we did not have a platform like AWS IoT. Otherwise, we would have directly started to use those services. But I can clearly see how this will match to the AWS IoT platform. Moving on, so these are the different applications of fleet management. Roller mobile application is available for retail users. App-based infotainment is like it's like Android Auto on your mobile app. So this is something that we are building for one of our OEM customers also. Talking about the data that is flowing from the from the devices, be it vehicles or in machines. So these are the kind of different data that is going. So location data, driving behavior, diagnostics data, configuration data, and security and exception events. So large amount of data is sent to the cloud, and that's just from one endpoint. Now imagine having tens and thousands of these devices sending data to your cloud. That means you need to have very scalable, very secure kind of platform which supports multiples of devices, and of course you need to probably open up your APIs for third-party applications, building domain specific applications. And that's where I think I can clearly vouch for the IoT platform that AWS has, basically because it has all these different components. So any component that you can imagine, I think AWS has already built, and it's a very mature platform, starting from the edge, to the cloud backend, where I think Gabe already covered about device management, security layers, and going up to the application layer, right? So our journey with AWS, as I said, we started in about 4 years back building cloud from the ground up. So we were earlier using mostly the infrastructure services, basically the Amazon EC2 instances. At one point of time, we were running about 14 to 15 instances in a VPC cloud, then using Amazon CloudFront for rendering web pages, and of course S3 for raw data storage. But what's happening now is basically we are going to replace each of our existing components with these services from AWS. So we have already replaced the AWS IoT core as the gateway, the first connectivity part, then Lambda functions, Kinesis streams, and of course the Alexa and other voice services that AWS has is going to play a very important role in the connected car ecosystem. So that's where we are looking to use Alexa, Polly, and Lex. Just quickly talking about how the migration is looking like. So as I said, that the connectivity gateway we have already replaced with AWS IoT core. Then we are looking to replace the different device management capabilities that already AWS has. Of course, analytics and other device management capabilities. So some obvious benefits, I think Gabe has already discussed this, but you get all these features out of the box: device management, device shadow, load balancing, scaling, and security, right? So you can just basically offload all this tasks to AWS. Talking about AWS IoT at the edge, I think it's very important. This is one of the products, kind of emphatic cockpit that we showcased at CES this year. It's basically a cockpit that can transform in its behavior once you are there. So it can do a driver recognition and kind of modify the environment to suit your preferences. A solution like this would require lots of decisions to be taken at the device level or at the car level itself, and that's where the AWS IoT at the edge will be very, very important, right? So local machine learning instances which are trained in the cloud could be deployed on your car, and which will enable these kind of decisions to happen. Finally, what the future look like with us with AWS, I think AWS we are already using for powering our connected fleet. So not just cars, but all sorts of vehicles are already kind of using the AWS cloud with these components. And we are also integrating the Alexa voice service in the car, in the infotainment system, so you can focus on driving and offload your queries and other task actions to Alexa. And outside your car, if you are at home, you can just query. This is something that we already done the integration, so you can just query Alexa, where is my car? Alexa talks to our cloud, and they can send a response to you basically. So overall, looking fantastic, and we're very excited, to work with the AWS team. I think they have a very fantastic, roadmap going forward. So we are kind of hooked onto the ecosystem, and that's all from my side. Thanks. I think over to you, Gabe.
Okay, back on. Can you guys hear me now? Okay, good. Thank you. So something that Amit just shared about that I want to spend a little bit more time on, because I think this is really neat, is how can I extend the capabilities of the Internet of Things to the edge? Even more so already, right? So I already talked about Greengrass. And Greengrass already has some capabilities, right? It can run local lambdas automatically based on triggers that are happening for devices communicating directly with the Greengrass device without having to be online to the cloud. Of course, it can manage data and state synchronization, and it can do this all in a secure fashion, acting as a local certificate authority, as I already mentioned. But there's a few new things that Greengrass can do. One of them is over-the-air updates. Now, you could always do over-the-air updates of your business logic, your lambdas, right? You could always do that. But now you can actually manage the over-the-air updates of the Greengrass execution environment itself. And that's something that's pretty nice. So you can decide when you want to update the Greengrass version on your Greengrass devices. Secondly, we now have a protocol adapter for Opc Ua. Now, if you'd have never heard of Opc Ua before, not exciting for you, but if you have, this is probably really cool news for you. Opc Ua is a communications protocol that's really big in industrial applications, right? So maybe the motors on the belt of a factory, of a conveyor belt, for example. So all these customers are coming to us and telling us, this is great that you have Greengrass, but we have already a lot of data we're collecting in our factories to a hub that speaks Opc Ua, and we would love to send that data into Greengrass for local execution and all this stuff. Well, now you can. And another area is local resource access. So now the Lambdas that you're writing, that are running on the Greengrass device, can take advantage of local resources that the Greengrass device has. That might be file system storage. That might be a GPU to run some accelerated machine learning instances, for example. That might be a hardware security module. Doesn't matter. Now you can not only can Lambdas access local resources, you can also manage which Lambdas in your Greengrass deploy should access which devices. So that's all configurable now and manageable. And most exciting, though, is this. Now you can do local machine learning inference on Greengrass devices. And I want to unpack that into a little bit more detail now. So what do I mean when I talk about local machine learning inference on Greengrass? Well, what I mean is that first, you're going to go and you're going to train a machine learning model in the cloud. You've got a lot of data, and you send that data into a machine learning framework, and you come out with some model that's going to try and do something smart with that data. I'm speaking in very generic terms. I'll go into specific demos in a minute. Like in this case, maybe you want to identify dogs and cats, right? So you're going to send a lot of pictures of dogs and cats up online and train a model to identify them. Next, you want to deploy that model onto your devices, your Greengrass device, but that model should be optimized for the hardware it's running on, right? So we make that possible now. So whether that's an Intel Atom processor or running an NVIDIA Jetson chipset, even a Raspberry Pi, right? You can deploy machine learning models onto Greengrass running on these devices. And then finally, you want to run your application. So you're going to write Lambdas that are going to take advantage of that model that you've deployed to take sensor data in, run it through that model, and take smart local actions. And so, an example of this might be using the connected car topic that we talked about before, that Ahmed shared. I'm driving down the road at night, and I've got my high beams on because it's really dark, there's no street lights around, and I'm alone, and it's a wide open road. But then a car comes the other way. Well, it would be amazing if my car could be smart enough to know with its own camera. Right? I see another car is coming the other direction. I can estimate the speed that that car is traveling at, my angle from my headlights to the oncoming driver's field of view, and adjust my headlights accordingly, either just turning off my brights, or there are new car headlights coming out now that have individual LED arrays that can be dimmed in certain configurations, so you don't even have to turn them down completely, but you can just change them in a way that's going to give oncoming drivers a better experience. Right, that's just one idea. Another one that's really neat is there's a company called Yanmar. They're a customer of ours. They're a Japanese equipment manufacturing company, but they're also committed to building better farming techniques and optimized greenhouse techniques. They've got a deployment using AWS IoT and ML inference on Greengrass devices where they have cameras set up looking at tomato plants, and they've trained models to automatically recognize the different stages of growth in these tomato plants, and on an individual level tune and adjust the mix of fertilizer or watering and things like that to optimally grow tomatoes in a greenhouse environment automatically. It's pretty neat. So to sum up, what's the full state of IoT with AWS? Well, first, you've got the stuff that we support on the edge, right? You have endpoints using the IoT SDK on their own devices, talking out over MQTT maybe to IoT Core, maybe Opc Ua, right? These can all be talking to Greengrass. You have free RTOS, which I don't have time to talk about today, but that Amazon free RTOS is a real-time operating system that we put out optimized to run on microcontrollers because not every device is capable to act as a Greengrass device. So we built a distribution of free RTOS that makes it easy to communicate with Greengrass devices in a secure fashion for microcontrollers. Finally, Greengrass can communicate with the cloud. We've got the IoT core for handling things like message brokering and rules engine evaluation, the certificate authority, managing your device shadows for state synchronization, and then the other things I talked about today, IoT device management, device defender, and IoT analytics. Now, I would like to go to a demo that I've prepared, but don't play the video yet if you don't. Okay, actually, we'll watch the video first, and then I'll talk more about it after. Go ahead, play the video.
Okay, so what we have here is an AWS Deep Lens camera, and it's pointed at this laptop. And we're just using this laptop as a simple projector screen. And on this Deep Lens, it's running local ML inference of a model that we trained to recognize popular Indian foods. And when it recognizes something, it's publishing this to a MQTT IoT topic. And from there, we're rendering the results in this Amazon Sumerian virtual environment. So you can see here, it thinks it's a dosa. So now we'll change to another popular food, and we'll see what she thinks it is.
My guess is it is Italy.
Well done. All right, let's try another one. Ah, everybody here should think they know what this is. It's delicious, right guys?
My guess is it is a pav bhaji.
You got it. Let's try another one. Ooh, something made with cashews, my favorite.
My guess is it is a kaju katli.
She's got it. One more.
My guess is it is a vada pav.
You got it. So, as you can see, this is working fine. Now you just have to take our word for it that this is running a local ML model because we needed to keep the Wi-Fi on, otherwise it couldn't publish to the topic that we were using to subscribe for this demo. But I promise it is, and it wasn't that hard to train using SageMaker.
So let me tell you a bit more about that demo before I wrap up. Some things that I think are really neat about that. One, I had this misconception that you needed a ton of data to train a machine learning model to do like image recognition, for example. It's not really true. To train that model, we took 100 images of each of those foods, right? 100 pictures of dosa, 100 pictures of kaju katli, of pav bhaji, etc. Only 100 of each, and said, okay, SageMaker, go learn. So SageMaker, as I mentioned before, it's our service that makes it easy to develop, build, deploy machine learning models. So and SageMaker also comes with a number of algorithms for machine learning optimized for various use cases. So in this case, we used one that uses transfer learning. So you've already got a neural net that's trained on how to recognize images, but not particular types of images, right? Just the concept of how to find the edges, what the color detections are, these sorts of things. And then we just said, okay, here's 100 images of what dosa. These are all dosa. Here's 100 images of kaju katli. And then from that, we trained the model. The model only took about 15 minutes to train in the cloud. We only paid for those 15 minutes of training time, by the way. We didn't have to have an expensive, huge GPU clustered computer set up in order to train our model. It was very easy to spin up one in the cloud, the AWS, train it with SageMaker, shut it down, we have our model, and then get that model deployed onto the device. The device you saw is the AWS Deep Lens. These are available for pre-order right now, and they're going to start shipping in June, I believe. And the Deep Lens is basically a computer with an Intel Atom processor and a camera and a GPU inside of it. And it's all made for this kind of ML inference at the edge, right? You can run Greengrass on a Deep Lens device. And so it was very easy to get that demo made. The only reason I'm not showing it to you here today live on stage is because this demo requires some really strong Wi-Fi connectivity, not to recognize the images, right? And again, maybe I should mention this specifically. The images that the camera was looking at were not part of the training model, right? Those were different images. That's why it's impressive that it worked. But I can't demo it today because once the camera detects without Wi-Fi, right, just locally on its own brains, oh, that's a dosa, that's sending the message out to a MQTT topic in AWS IoT, and that's why we have that virtual host in Amazon Sumerian to speak it. That's the part that doesn't demo well without a really strong internet connection, and unfortunately here in this converted aircraft hangar today, I wasn't able to give that for you. So Thank you for indulging me in a demo video, which obviously works every time. But we recorded that just a few days ago in my office. So I assure you it's a fresh demo. And we've also got a Deep Lens here today at the IoT booth. So if you want to see and learn more, please just stop by there to take a look. Finally, the last part about the IoT ecosystem here that I didn't talk about before is our partners. So taking all the data that you can produce from AWS IoT, leveraging other AWS services with it, like machine learning or Redshift for doing aggregations on a lot of data, using QuickSight for dashboards, etc. That's a lot. This is the most complicated slide in my deck. But using IoT doesn't have to be complicated, and each one of these things on its own is easy to understand. But we have a number of partners to help out with each one of these categories as well. And I would be remiss if I didn't mention them and all the support they can provide to you if you're working with AWS and IoT today. So that's it. We've already seen the demo. So now I'll just say thank you. And if you want to keep in touch, the best way, for me anyway, is to follow me on Twitter. That's my Twitter handle. I'm constantly sharing updates. And I appreciate your time. Again, thanks a lot, you guys.